The first thing that you want to notice is just this stuff over on the side. This over here is just vocabulary. The first thing written there is called the objective function, and then the stuff we're about to graph, those are called constraints. So we're going to graph x is greater than or equal to 0, and we're going to graph y is greater than or equal to 0. So if x is greater than or equal to 0, that would be a vertical line, and greater than is going to be to the right. Y is greater than or equal to 0, that's a horizontal line, and greater than is going to be up. So I know that I'm only using the first quadrant. Then I go to graph the third one, and this is in standard form, so your teacher would suggest that you leave it in standard form and just find x and y intercepts, because you're going to make more mistakes if you have to solve this equation. So I would leave it and find x and y intercepts. Remember, to find the x-intercept, you make y 0. So x-intercept is 4. To find the y-intercept, you make x 0. So the y-intercept is 2. You use your straight edge and you connect it. And since it's only in the first quadrant, I really don't even have to draw my line longer. Then to find which side is shaded, we test a point. So I'm going to test 0, 0 to see if it works or not. So I plug in 0, 0, and I get 0 is less than or equal to 4, and that is true. So I have to shade this line towards 0, 0, because it's true. And then the fourth one, I'm going to do x and y intercepts again. My x-intercept, I make y 0 and I get 1. My y-intercept, I make x 0 and I get -1. I use my straight edge. I test a point. I'm going to test 0, 0 to see if it works or not. And I plug in 0, 0. I get 0 less than or equal to 1, which is true. So I'm going to shade towards 0, 0. So after all the shading, the correct shading, we have this little quadrilateral. And we have to test vertices. So we have to find all the vertices for this quadrilateral. So there's 4 vertices. Those vertices, one of them 0, 0. And one of them is 0, 2. And then 1, 0. And then 2, 1. And when we test the vertices, you're just taking the vertices and plugging them into the objective function. And for this particular one, it's asking for the maximum value, but I know in your homework it asks for maximum and minimum, so you'll have to find 2 answers. For this one, we're just doing maximum. So I'm going to plug 3x plus 2y for each of these. So we'll do 3x plus 2y is equal to 0. 3x plus 2y is equal to 4. 3x plus 2y is equal to 3. 3x plus 2y is equal to 8. And then I see that my maximum value comes from 2, 1. So on my little solution blank, I'll write 2, 1. Eventually, we don't really need it today, but eventually we will describe what the max value is also. So I'm writing it today, but you don't necessarily need it in your homework. So this is the first part of what our next section is, which will be real-life application of where you would use this in a business, maybe, or maybe engineering, something, possibly, in the future. And then your assignment is just, let me split the screen. The assignment is just book page 5, 29, 13, 14, 17, and 18. And I've provided graph paper. You guys can just put your work on the graph paper along with your graphs. Okay? And then if you lose that graph paper, I also put it on Canvas. So you can print out as much as you want. All right.